Well, welcome everybody, and thank you for joining us. We're here today to discuss AI, healthcare, and cybersecurity, together with Hub Security's very own North American Vice President, Gaurav Sharma. And we're also joined by a number of AI and healthcare experts, including Senthil, Kumaran, Dutta, Mitali, Matul Shah, Jem Unsal, and Ravindra Patil. So thank you all for joining us today, and I'm very much looking forward to the discussion we have ahead. We're going to start our webinar with a brief introduction from Gaurav Sharma on cybersecurity's role within healthcare, big data, AI, and then our panelists will each get a chance to briefly introduce themselves. And afterwards, we'll get into a bit of a deeper discussion on everything related to AI and healthcare, including its challenges and solutions. As usual, we'll leave about 30 minutes at the end of our discussion for a Q&A. So if you have any questions throughout, feel free to drop them in the Q&A section below. And if you can't find the Q&A section, feel free to share them in the chat. That's fine too. And we'll get to them later on in the discussion. Now, we have an impressive lineup of panelists tonight, and I'm excited to have them introduce themselves to you. But first, we'll begin with a few words from Gaurav Sharma, the North American VP at Hub Security, and then we'll hand off the mic for introductions from our panelists. Gaurav Sharma, welcome to our webinar today. Take it away.
Thanks, Sterni. So everyone, my name is Gaurav Sharma. As Sterni mentioned, I am responsible for our business in North America, and Hub Security is a cybersecurity company that focuses on a security paradigm based on a concept called confidential computing. Now, welcome to the webinar. This is a fascinating set of panelists that we have assembled. But before we kick it off, I would like to take a couple of minutes just to set the context. We get people from various different backgrounds, both business and technical, so usually it's helpful to talk about what we're going to mention today. So just to kind of set the context, 30% of the data that is generated today is generated in the healthcare industry. Now, this amount of data, as well as the advances in artificial intelligence, have actually started helping healthcare professionals make better decisions by augmenting them with insights and really improve the whole patient outcome. We have experts in the field today with us, the field of artificial intelligence that focus on telehealth, medical imaging, personal health, data science, predictive analytics, and they'll help us demystify some of the advances and the use cases in the healthcare industry. So with that, I hope that you enjoyed the webinar. And with that, back to you, Sterni.
Thanks, Gaurav. Thanks for providing some context for us. Now, I'd like to take a few minutes just to do a quick introduction round. So starting with Senthil, would you mind giving our audience a bit of background on yourself and your field of expertise?
Thank you, Shari and Gaurav. My name is Senthil Kumaran. I started my career as a technologist way back when microprocessors were in existence as 8088, 1985 programming. Today, I work at Virtuwell, which is a telehealth division of Health Partners in Minneapolis, Minnesota. Virtuwell started 12 years ago when telehealth was just a buzzword. And after pandemic, I'm pretty sure everybody knows what telehealth is and digital health is. So we started our predictive analytics AI team 5 years ago. Virtuwell is one of a kind telehealth platform where every interaction from patient is completely digitized. And we don't do video visits. So there is an intelligent questionnaire that asks the right kind of questions to the patients, and we route the patient encounter to the right clinicians. And so that's what we do. And my role is I'm more a CDO, CIO for Virtuwell and work for different initiatives inside Health Partners. So that's it.
Great. We're really glad that you could join us today. Thank you, Senthil. Dutta, why don't you go next?
Thank you, Shirley, and nice to meet you, Senthil, and other co-panelists out here. Myself, Mitali Dutta. I am the head of data science and predictive analytics within the group IT division for Philips. I'm based out of Bangalore, India, and being into this for last 2 decades in the world of technology, data, and analytics. And currently my role entails in group IT, driving the data technology driven strategies for the enterprise applications and doing predictive analytics for the enterprises, sales, marketing, finance, into the health technology side of the business. So pretty much B2B, coming with an experience of analytics in the retail financial investment sector. And this is my new passion, which is healthcare right now. Having seen the pandemic COVID, I can personally relate to now everything that I do in this business. So that's me, Mitali.
Thank you. And thank you for joining us. Let's go to Matul next. Matul Shah.
Thank you, and thank you for the invitation to speak. My name is Matul Shah. I'm the VP for AI products at Proscia. My background, I've had about 20 years of work in the healthcare sector, specifically in the software sector. Most relevant for this conversation, I've had about 8 years of AI healthcare experience. Working primarily in the radiology space, working with breast cancer. And then currently where I am right now at Proscia. Proscia is a software company developing image management platforms for pathologists to be able to view their tissue samples and moving it over from microscope to monitor. And my team, and part of my thrust to be able to take advantage of the digitization of pathology and be able to develop new AI applications that can work in enhancing the lab's efficiency, enhance the pathologist's accuracy. And so very excited again to be on this panel, and I look forward to the next hour.
Great, thank you, Matul. We really appreciate you being here today. Ravindra, why don't you go next?
Thanks for the invite, first of all. And I'm Ravindra Patil. I'm the group lead for data and AI team within the personal health cluster of Royal Philips. This is a team consisting of data scientists, data engineers, data analysts who work all together to deliver solutions for personal health. Bit of a background, started career with healthcare almost 14 years back with one of the giant in healthcare. All through, it has been associated with data, signal, images, and AI. Worked on ECG signal, CT, MR, and later on moved on to predictive analytics on device log data, now currently with personal health. Quite excited to be part of this panel and looking forward to the next few hours.
Wonderful, and thank you as well for being here. And last but not least, we have Jem Unsal. Go ahead.
Hi, my name is Jem Unsal. I am joining from Optum, part of United Health Group. I'm a recent transplant to healthcare. I joined Optum early last year. But before that, let's call it a long journey. I'm gonna date myself. Senthil said, 8088. I'm from the 6800 family. My professors did not like Intel. We did all Motorola. That's how I started. I'm an electrical engineer by tradition. But I started touching AI, ML. My dissertation was in learning automata. The application was self-driving cars. And then I moved in and out of AI, depending on what I'm working on. I've done a lot of advertising technology, a lot of search and the web early years, or the mid years, if you will. Then I moved on to ad tech, which was, again, a lot of AI, ML, graph technologies. And then I spent the last 8 years, just before I joined Optum at Intuit, and we were basically using AI, ML to create tools for basically our developers and our subject matter experts. You would see a lot of change if user of TurboTax or QuickBooks, there's a lot of things that's happening in the back that you don't see, but Intuit is gaining momentum for a reason, and most of it is basically technology driven. And most recently, initially I joined a group called Advanced Technology Council. whose mission was only one thing, which is do AI ML for healthcare. Look at everything that's possible in clinical claims, speech and language, and data technologies, and see what can be done. Optum is a very large company. There's both UHC side and the Optum side. So there is a lot to be done. One of our proof of concepts become an enterprise level funded project, which is search. It's going to be an interesting ride because we only have close to 80 different contents that we need to search and merge. And I'll tell you more about that. I'm very happy to be here.
Great, thank you, Jem. Thank you for joining us. Yeah, so let's move on to our discussion for today. Just as a quick intro, we're going to divide today's discussion into 3 topics. We'll start with our first topic, which will be a general overview and introduction to AI within healthcare. Then we'll move on to our second topic, which will focus around challenges and risks, followed by our third topic, which is approaches and solutions. So just to start us off, I'm going to ask a question to our panelists, so anybody can feel free to respond. So just to start us off, my first question would be, what is AI in healthcare, right? AI can mean very different things to different people. Maybe some of you can help provide us with a definition or a clear picture of what AI is within the context of the healthcare industry. And feel free to just...
It's a tough one. Who wants to go first?
Yeah, let me go first then. Thank you, Shani. I guess AI, artificial intelligence, and as when Sam was talking of his era, even 2 decades back when we started, it was all machine learning, and now we all call it AI. Just because all the embedded insights and the predictions are getting attached to the application, to the device, to actually what we're using, and hence artificial intelligence in the healthcare has become so important to make sure there's a personalized care to the patient, efficiency back to the physicians and the doctors out there, because that's where they spend a lot of time, looking at multiple reports, multiple scans to treat the patient. So AI in the healthcare is to basically give back that value time to the doctors or the physicians or the technicians to do their job right. And in our world, where I'm coming from, which is health technology, so we have system devices. So for me, AI is that software which we are attaching to these systems and the devices, such that the device in the system, the information or the data which it is capturing, it gets massaged at the right time, it gets interpreted at the right time, and it throws the information right on the screen that the doctor needs it right there to take his decisions. So that's for me is the AI right now in the health systems. And that's where we are doing a lot of work to make sure we do embedded artificial intelligence solutioning to our devices. But also at the back, the AI does a lot of work for us to make sure our enterprise solutions and strategies work. So there are 2 folds to it in the health tech at this time. And it's technology at the heart of it. So when you say AI in the healthcare, it's all at the end is the technology. So that's for me is the AI to begin with.
Wonderful. Thank you, Dutta. Does anyone want to add anything on to that?
I can add a couple of things. By the way, Dutta, I'm going to use your description. It's a very good introduction, at least what we expect from AI. So I'm going to, instead of trying to describe it, I'm going to tell you what I think AI or machine learning can do for us in our company. There are a couple of, there's a lot, by the way. And sometimes when I discuss possibilities of AI, ML, actually, I don't use that word because sometimes it's overloaded depending on who you're talking to. So I use automation. Sometimes they don't need to know what's happening in the kitchen, right? I solve the problem, I hit the KPI, everybody, it's maintainable, it's stable. So, then you maybe introduce AI, ML. You can tell, hey, there's actually magic happening behind it. Some of the stuff, by the way, the recent changes, I cannot understand. I go to the scientists and then can you explain this black magic to me? Because some of these things are, we'll get into explainability maybe. It's very interesting. There are 3 things that the machine learning and AI, new technologies can do for us. One is data. The data is so big and so diverse, and it comes with noise. We're doing healthcare, we understand, there are faxes coming in, somebody scans it. So there's a lot of things, there's a lot of tools we can use to make data better. So make our platforms ready for machine learning. Because in some cases, there has to be, the platform needs to move to that next level. There's a lot of things we can do on decisions. Now, that's a tricky topic. When you talk to a doctor and say, look, we're going to make decisions just like you did, they're going to be like, no. So what we're trying to build is actually tools that will help them. And these tools will be, we're not going to make the decision for you, but let's make sure that you don't miss any information about that patient. When you're looking at something, we will bring you all the documents that are available to you in front of you in your dashboard, so you don't have to shuffle. Like, don't spend half an hour. Finding will be fast, so you can make the decision. You'll have more time to make the decision instead of just trying to find the data. That is, I think, very powerful. On the software side, we can do a couple of things. One is, of course, automation. There's a lot of things we can do, including creating the software that's going to do the automation. So, like, let the AI build the AI. And then the one that when you go in front of the customer, I'll give you an example. We're going to try to do search. We have search in our company. Multiple groups are trying it, but we never try to combine, as in, yes, you're looking for a doctor, but actually as a company, we have a lot of information that we can use to make that search better. And when you start doing that, everything I discussed comes into play, including machine learning, AI, deep learning, NLU, NLP, which can start doing extra additional things for us. And some of them are actually very impressive. So that's how I see what AI ML can do for us in healthcare.
Thank you, Jem. Thank you, Jem and Dutta, for a wonderful definition. Just to bring things into a bit more into context a bit more, what are some specific use cases which we can see already either being implemented or that we can expect to see within the next coming years?
I can give some examples. I know both Mitali and Jim are talking about augmented AI. There are more than 50 FDA approved autonomous AI solutions. So there is a huge difference between augmented AI and autonomous on the healthcare space. Imagine if a treatment plan with a prescription can be rendered by an AI engine without a doc looking at it. Like 15 years ago, we were thinking about the self-driving cars would be like the first autonomous AI solution that we will all have. But today we have more than 50 autonomous AI healthcare solutions, which FDA has approved. I'll give you 3 or 4 examples. Teletherapy, there are a couple of examples on the behavioral health side. On digital dermatology, there are a couple of AI solutions which can actually find the skin lesion and create a treatment plan. And there are a couple of companies on the eye scan which reduces the retinopathy, diabetic retinopathy. Viz.ai and AI Doc are doing it on the lung side. Rapid AI is doing it on the central pulmonary embolism. So these are like autonomous AI solutions which are already approved. And there are 50 more you can go read. So what this is doing is it's reducing the overall healthcare cost. And it has a much higher accuracy than what we have as benchmark. So a lot of people are thinking this is futuristic. It's going to happen in 10 years or 20 years. So what I'm trying to say, it's already there. Even before the self-driving cars, these autonomous AI solutions are already existing in place, and it's changing people's lives.
Thank you, Senthil. Yeah, and maybe you can talk a little bit about, just to expand on your point, about the role of AI within patient-centric treatment approaches.
I can talk about at Virtuwell what we have done at a patient-centric level. So in the pandemic, I'm sure everybody knows that we have more than 1,000% increase on telehealth usage, especially on 2020, right after when clinics were all closed or most hospitals were struggling to meet. So what we did from a patient-centric perspective was we did all the wait time calculation. Previously, we were doing first in, first out. Patients come in, and then we have predicted how many patients will be coming in, and we had that many number of clinicians to work on these patient cases. So it was an easy problem to solve, isn't it, from predictive analytics perspective. But COVID threw everything out of the door for us. So we had to go figure out what is the exact wait time that is going to be. And then instead of first in, first out, we have to do reprioritization and a lot of newer things. So the one thing that we did during pandemic was to launch the at-home lab kit for colon cancer screening. So this was a big change because now you don't have to walk into a lab to do colonoscopy. So the FIT kit is just collect the sample, you send it to the lab, and you can all do it from your home. And so we launched this one for a small pilot of people who are above 50. And so that proved to be a great success because now people don't have to leave their home. Send all of your samples in a prepackaged envelope. We also launched an STI kit, at home kit. And so these two were very patient-centric, and behind the scenes, there are a little bit of AI involved in like who's going to respond back and who is going to have the need to go to colonoscopy. But all of it happens after the lab processes the results. So we get it back, and then the clinician will talk to the patient, and this all happens by both the clinician sitting at home and then the patient sitting at home. So this just skyrocketed. What I say is like this last 2 years had made a lot of these changes possible in a faster way. So now we've avoided, like, for more than 99% of patients, the colonoscopy. So the amount of frustration and anxiety that we have avoided. Forget about the cost savings, but I'm talking about like the anxiety that you had to go through colonoscopy, wait for the results. So this is much faster. So this all happened in the last year at our company. So one example.
Fascinating. Really interesting. Ravindra, talk to us a little bit about how different the development of AI models are within healthcare compared to other industries.
Yeah, I can throw some light there. First on the definition itself, right? The definition doesn't change of AI with respect to industry. The textbook definition remains the same. I don't take anything different there. But AI in healthcare has a different meaning for me. The reason is two steps there. Before any AI models are getting created, one is about the data quality that comes into play. Although, Gaurav, you mentioned 30% of the data is generated in healthcare, and it's also a top 3 in the top of industries which generates the data. The challenge is access. It could be of multiple reasons why it is so, right? It could be political in nature, it could be what is in it for me, or it could be ethical in nature, saying it's a patient data, why should I share it? Or it could be also on the quality of annotations on the data itself, right? So one of the significant change that I see with respect to other industries than with the healthcare is availability of high quality annotated data, which could be used for delivering these data and AI solutions. Yeah, that's one. Second thing is about acceptability of it. If we get sick, we want a precision diagnosis to happen quick and early. In order to do that, we need millions of data points, which somebody else has to share, such that these kind of decision systems are made available. Now the question is, am I willing to share my data, which is for good for the other people? Little of ethical in nature. And this is fundamentally a bit different than all the other industry where the clickstream data, the search data, which is openly available. Second is about the precision or the accuracy of the models that we are developing in healthcare. If you take any of the e-com or so on, a recommendation system comes up with a cat or a dog or a bat with the ball, you just go through it, right? There's nothing harm except somebody would have their KPIs not being met with respect to volumes or revenue, but that's what is going to impact. But if you take a healthcare, if I say a lesion is not there where the lesion is there, then that is significant. Yeah. So the quality of AI models that are going to come up, and with all the scrutiny of FDA and the regulatory bodies, it becomes challenging compared to other industries. So one is on the data access rather than availability, I would say access. The second is on the quality of AI models that really make a difference rather than just a POCs that are of not much use within the healthcare.
Thank you, Ravindra. Jen, talk to us a little bit about data equality within AI systems. And this, I think, is super important, specifically when it comes to healthcare, since people's lives are on the line. Is the healthcare industry really ready for these machine learning models?
Ooh, that's okay. So you guys have a couple of hours to discuss just this topic, right? This is not an easy one. So when it comes to data, our problem, and this is based on the last 18 months of experience that I have with core data. This is everything: clinical, claims, benefits, etc. So there are a couple of problems. One is, it's specific to us, but healthcare is actually very distributed. It's everybody's problem. We're big, but there is, first of all, too many feeds coming in. Because of the size of the company, the mergers and acquisitions is constant. We can't even merge new technologies into our system faster than the amount of new incoming technologies into the overall system. So because of that, there's always multiple feeds. There's always the need to get as much as possible. And then, that's a problem in itself, because you get 3 feeds, you have to merge them. So this is assuming the quality is there. Now, some of our data is coming through faxes, so we need to translate that. That introduce some noise. We can do a pretty good job with that, but we're not always there, because there's always, this is, when you do AI ML, that there's going to be always an X percentage of errors. We can actually statistically guarantee that there's going to be this many errors. We can say, look, we're going to automate 80% of this, but there's always this error. The question is, where do you want to operate? How much error you can handle? I can automate more, but you need to be able to take on a little bit more errors, or find a way to, recover that through, maybe non-automated ways. So there's always the merging side of the problem. The data quality definitely changes. I've been doing this for maybe 15 years, looking at data, try to massage the content into AI machine learning compatible format. It's not always easy. And when you merge this data, you have to actually kind of go one level deep to look at not the source, but the actual fields in the data to say, look, I'm getting 3 sets of data, but I'm going to, for this specific field, it could be just the name of the doctor, that I'm going to trust these feeds more because I know they do a better job of cleaning or double checking, auditing their information. So there is that one. And all of these, actually, most of them are custom designs. You can't go buy this one from an existing company. So most of these have to be built in-house. You don't see open source solutions for these. So that's, we're not there yet. The noise issue, we have a pretty good idea how to detect or what to figure out. The quality, updating quality. I'll give you an example. We are actually looking at some benefits data, and we already have some ideas around augmenting what we're seeing to do a better job with search, bringing the right policies in front of the user. But now we're at the point where we realized, what we augment, we need to return back to the system. And the question is, where do we tap it in? Am I tapping it on the original document, into the XML, into the JSON, into the database? We don't know yet. And actually, we don't have control over it, because the other party is going to tell us, this is where you're going to come in. And that's a lot of engineers talking to engineers. So there is that one that we're kind of realizing, this is interesting. We didn't expect to work on that one, but we realized there's a lot of content that needs to go back to the original, the source of truth. The technology is there. One problem we're seeing is actually the connections. Sometimes you have to get the buy-in from the owner of the data / content to work with you. And, depending on who you're working with, it could be a third party, it could be an internal group, that discussion needs to happen, because at the end, you need to provide them. Yes, you want to take their data, you want to do something interesting, but you have to sell it back to them, saying that, look, you're going to put 2 engineers and a product manager on this, but let me look at your KPIs, and then I can tell you I can do this. So it's very interesting. That discussion is a different level. We have a reading group where we're reading machine learning design patterns. what I discussed is not part of those design patterns, which is actually very interesting. Like, what are those patterns? They're not software engineering patterns. Is it product? I mean, why the business schools are not discussing this? It's a very interesting problem. There is more, but those are the two big ones that I'm seeing these days. Or those are the ones that are keeping me awake.
Yeah, and if I can add
Thank
to
you, Jem.
that.
I think so.
Oh, go ahead.
Yeah, go ahead. Go ahead.
I was just going to add to that. I think those are two really interesting points and kind of dovetails into what Senthil mentioned about, the products exist. They're out there, at least on the medical imaging side. He mentioned AI Doc and a couple of others. I think related to data, to kind of continue that conversation, I think what we're seeing that needs to be proven. Yes, they exist. We have the performance metrics, but what we need to see is AI in the wild. And what I mean by wild, I mean really putting AI into many different situations, many different clinical workflows with a variety of different data sets, and figuring out how it actually works without all the massaging and proctoring and curation that goes into what is needed to be able to get AI to work as we're expecting. I think there's a lot that needs to be done, but I think there is a concerted effort, I know on the radiology side and now on the pathology side, to be able to get the products, get the AI into the wild, get it in, make some mistakes, get and learn really quickly from that so that we can actually deal with data situations that have a variety in nature, heterogeneous in nature, and be able to be successful at.
As we are into it, so let me also add one, Shani, if I'm not taking away the time for the section or the session. So dovetailing to what even Ravindra mentioned a few minutes back. Typically, there's a clinical data and there's a patient's data, but where we belong to in the health systems business of healthcare as an industry, the AI for us also practically happens to keep our devices up and running. Imagine hospitals where our devices are installed. A predictive or preventive maintenance is critical for our success. It's in our contractual agreement to make sure our devices are up and running when the 24 hours of a case is being created. And we should really avoid, our breakdown of our devices. So typically where AI comes in, so these are machines, these are log data that we gather from the devices. These are connected equipments at the hospital sites. And sometimes we might have a Philips equipment versus another competition equipment. And both the devices are sending log data. And as a part of managed technology services contract, we might have taken the maintenance service in our contractual agreement. When these multiple device data comes, the biggest problem while applying AI to understand the predictive maintenance durations, you end up having two different set of data, and you need interoperability to make sure they can talk to each other. You can bring it together in a place at what Sam was also mentioning to make sure you've applied the right data model, you're interpreting it right, and then you are putting forward the expected failures that can happen. So this is a very practical example in the devices business, doing predictive maintenances by reading the log files and making sure devices are up and running at our hospital sites, and we can avoid minimal, breakdowns, and case activities can be reduced. So just wanted to add another practical example of it.
Thank you for that. Gaurav, I want to take a little shift over to security for a second. From a security perspective, what is different about protecting AI in healthcare?
Yeah, so from a security perspective, healthcare is actually one of the most attacked sectors. Last year, I think 40 million patient records were attacked, and it's one of the most regulated as well. Data privacy and regulatory requirements come into the picture as well. So the conversations that we have is, hey, how do I secure AI? And it's really about protecting the model itself, and the other key ingredient is really data. And it's really boiling down to, I have data spread out across the infrastructure. I have models accessing this data. How do I protect them? How do I make sure that there's privacy preserving approach that I'm adopting? And then how do I make sure that I comply from a regulatory perspective? And then as Ravindra was talking about, I think the other big piece is how do I make sure that we can share the data effectively? So those are some of the key themes which are very specific to the healthcare industry because of just the nature of how it's regulated and the kinds of attacks that they see.
Thanks, Gaurav. And Jem, I see you shared the link to this book. I don't know if you meant to share it with everybody or just the panelists, but feel free to share it with us.
I'm not connected to those people. It's from, I think, a GCP, but we kind of like the book. It's we want to create a common language. So when we go in front of our customers, internal partners, other engineers, you tell them, hey, there is XYZ in machine learning, and this could be like designing, getting the data, delivering. So, and design patterns work really well for software since the 70s. This is a little bit different for machine learning. It's not complete. You can see this as an alpha version of this book, but it's very useful. I'm trying to build a common language. So when I discuss machine learning, what we're going to do with machine learning, this will enable us to have a reference point. I don't want to discuss, I don't want to introduction to embeddings every time. If everybody knows about it a little bit, and the suggestion is read the first chapter and the 8th chapter, you get an idea, and then just read as you need it. Not complete.
Okay, I'll go ahead and share it with the rest. Dutta, one more question for you, and then we'll move on to our second topic. How would you define an AI/ML data strategy, and what are some of the key components of a successful one?
I think, as everybody spoke, in the AI and the healthcare, back is the data. And if the data is not brought together, right, or strategized, right, we don't get the results that we expect. AI is the last thing. We have to first make sure as the KPIs are right, and we should be able to do performance management. So we do AI/ML data strategy or any kind of a data strategy. I think the core is the optimization, which is your cost, right? Optimization to make sure you're making profits. So your top line versus bottom line. So whenever any data strategy is getting organized towards AI and ML, the first thing we have to think is, if it's the top down, what is the automation is required to make sure that the process, the market understands why they need it. And then comes the bottoms up. Because at the bottoms up is where you introduce the technology, you introduce the continuous improvement mechanism, you introduce Kaizens, and that together makes sure that you understand what exactly is needed in this strategy. You have to switch off an application A versus an application B to migrate the data from another location. Do you need the cloud, or do you need standalone, mechanisms to make sure the data security, sanity, and privacy is taken care, but you're able to make the data flow. So the end-to-end data strategy actually resides on this principle of a top-down to bottoms, but also making sure that the architecture which drives the strategy is also understood. So these are the three things that actually goes within it. And then when you're doing the bottoms up is where all the core comes into of the data strategy. You need to have the right data governance, setup. You need to have the right data quality measurement mechanisms. If you're moving data across, then you need to have the lineage under your control, because you do not want to end up into a situation wherein you started with 100 records, you ended up with 10, but you don't know what happened in between. You really need to know how the data traversed, because if within the 10 something happens to a record number 6 or a 5, you have to trace back and make sure you know where the problem happened. So lineage is another component. And then, as Gaurav mentioned, access and security to the core, because we are into health care industry. You take a device data, or you take a clinical data, or a patient data, it's all needs to be secure. You cannot afford to get into the trap of FDA when you end up doing something. So in this data strategy, these are really controls that you have to make, establish in your processes, and make sure your data strategy takes care of it. And keep architecture at the core and drive it to technology is where the solutioning happens. So top down and bottoms up, both have to come together to make sure the optimization happens.
Wonderful. Thank you, Dutta. Wonderful summary. I want to move on to our second topic, and just trying to keep in mind the time. Our second topic is related to risks and challenges of AI within healthcare. And I'll start you off, Ravindra, with our first question. Maybe you could talk about some of the major challenges that come up in the development of AI models for healthcare, specifically within health?
Yeah, thanks for that question. We briefly touched upon. Let's not take the data as one of the other aspect which has already been discussed a lot many times. So I'll not touch that part. Right. Let's dive in a little bit deeper into the technology piece of development of the model. Right. One of the healthcare challenge, it is based on where domain the company operates in and which domain the deployment of this AI model happens, at least in the personal health. One of the challenge for us is all the models that are being built, which have a level of accuracy which could be taken up for the production, are with deep learning or with a memory which is quite large, almost more than 200 MB or so on. And if we want to bring these kind of models onto the edge device, it's a challenge. So one of the thing is, how can we build high performant AI ML models which could run on the edge is one of the challenge in the healthcare. Although it might not be in some of the cases where the models are running onto a cloud, where the data transfer is acceptable, the delays are okay. But if you want to have it something onto the edge, we still see a challenge in the healthcare. Very simple example, we have power toothbrushes. We tell which location of the mouth people brush, what was the amount of time they brushed, and so on. And then we really provide the oral hygiene score out of it. The question is, can the edge device of a toothbrush handle some of the deep learning models in a real time? That's not. Another aspect is, if we deploy onto the edge, the security aspect of these models plays another vital role. Yeah? Are they secure enough? Can the adversarial attack doesn't happen on our models there? Is it possible to ensure that the model weights are not stolen? And can the IP be protected in a B2C mode? So this is and the challenge with coming to edge inferencing for us. Other is, I touched briefly, which is about precise diagnosis leads high quality AI models. And for that, the regulations coming in, typically in healthcare, we were used to lock software, right? You release a version 1 of your algorithm and then, yeah, it's all working fine, we leave it. With this continuous learning models coming in, even the regulatory aspects have changed. But now question still remains, when do you say the model is not to go to regulatory to get an approval and then it can be go for deployment? And when is that case when it's good to go? Yeah, because the regulations are also in a style that, only the significant change has not been done to your model, then you don't come to us and we approve it. Then what is that or when is that is still a question. Yeah. So these are kind of predominant for me. I won't touch the data part of it because a lot has been spoken about it. But on the application side of building AI model onto edge and the regulatory aspect would be two key highlights from my side.
Thank you, Ravindra. Dutta, maybe you can expand on this for us. What are some of the core capabilities of a modern AI machine learning models data architecture? What are the core capabilities that should be included that weren't touched upon?
So I think I touched upon the strategy, and within strategy, architecture is the heart of the strategy. And when you're doing the architecture, you have to keep the user at the heart. That means the one who is going to make use of it. Be at the end, it is the clinician who's end up using your solution, be it at the end, it's the technician at the radiology department who ends up using the solution, or be it the hospital chief technology officer who might end up using your solution, or a biomed who ends up your solution, right? Because we are not getting directly into the hand of the patients, because I'm from the health systems and devices equipment. But whenever we do the architecture, we also keep the user at the mind. So when you are designing the architecture and you keep them in the mind, you have to keep simplicity of the use. So keep it so simple that the adoption of your solution is natural. Otherwise, what you end up is an adoption challenge. So first thing on the architecture is keeping this principle in the mind. And then comes today in the modernization of the architecture of the technology solution, which we are talking about here. It's basically making sure the engineering is set right. data engineering principles have also changed in the last 20 years or so. Traditionally, the way we used to do and the technologies which we used to apply have evolved. They have not completely gone, but I think with cloud coming in, with Microsoft coming in, with AWS coming in, a lot has become modern. So you need to really work on the layering engineering. You cannot end up dumping the data into the lakes, but you need to make sure that on top of the lake, you have your layering technique. Typically in our world, we do like a bronze, silver, and a gold layer so that your curation standards are maintained. You know what I'm bringing into the bronze, what level of curation I could apply, what I could apply on the silver, and what curation can I apply on the gold. And curation happens through data modeling. So you really need to make sure in your architecture, you have it really neatly cleaned out and neatly drawn out. And then last is, no architecture today is successful if it's not like a service model, like IT as a platform, data as a service, software as a service, AI as an enabler, right? So in your architectural principle, the drawing which you actually produce has to be application agnostic. So the consuming party should be able to take it like a service. Come with any BI tool, come with any API, come with direct consumption, but you should be able to consume it easily. So the service mindset, like a data as a service, IT as a platform, is becoming a trend these days. And in the architecture, I guess these are the critical components that we have to take care.
Thank you, Dutta. Jem, how can businesses integrate some of their new AI ML solutions into current existing systems? Some of them might be legacy systems as well.
Oh, yeah. So couple ideas there. So first of all, everything, our experience, my recent experience on, building these models, between our, data engineers and scientists, building the models is easy. I mean, usually it's a problem of time and cost, but at least we know what we do. And then through, over time, you learn the experience. So you can build quick, meaningful models and the numbers will be impressive. Now, integrating it with the business for a specific project, so far, everything we've seen is case by case. We actually tried to follow the Google's model of, the definition of AI readiness. And when you look at the organizations or the system you want to try to integrate in, or our own system as ATC, we're somewhere in the middle. Because, out of 5 items of being, kind of ready for ML, we're in it because, we only operate in Azure and AWS and GCP. We try to stay away from on-prem unless it's a, very big, like a graph implementation, because having it on-prem makes it easier in terms of security. We discussed all of this. But, everything we build in that group and in my current project, everything is Terraform. We want everything to work on Amazon, and the next day you can actually go to Azure. Not easy, but we're pushing for it because in my case, for our search project, we have to be close to the data, and I can't really get into where they are. There's 3-4 different locations they can be in. So, but integration is, we've seen things, a couple of things. The examples we've seen, there were cases where we had a very good model, and we wanted to plug it in. It's basically a quick decisions on dental x-rays. And we knew we can do a very good, get really good results. Some of them are because what you receive as file is not really an x-ray. Identifying that one is very easy for a machine. You don't need a human for this. Actually, those images shouldn't see the doctor. There is no point. It's not an x-ray. That is easy. With the x-rays, we can do a lot of good decisions. The numbers were very good. But what we realized that since that flow, the data flow was involving a third party, integrating our model into this flow that involves a third party that's working with one of our businesses is nearly impossible. The cost was so high, there was no return on investment in this good model. We knew it was possible. We actually demonstrated. One of our scientists actually built this very nice system where you can actually drag things and, you can say how much errors you can afford and what's the cost. And based on those numbers, we will tell you exactly what the gain is. Are you going to gain $30,000 a month, or are you going to have $500,000 a month? It depends on your choices. But integration was hard. Did we give up on that one? No. Is it going to take another year? Yes. So there is that part, and it's one case. We had cases where the customer took the model, integrated it, assigned a data scientist to it so that they understand that there was a maintenance cost of this model. But what happened, the person left the group. moved to another project. They put another person which did not know the model, so there was a drift. It was a slow drift. It wasn't high. It was over the months. It's not like almost like a year. But there was a drift. They actually came back to us and say that, look, can you refresh this? Because we can't do it in-house. So that was a good example. And actually through that integration, the second iteration, they realized, hey, we can give you this new fields because this is going to make it better. That's a good example, right? There was a drift. There was an ask. We didn't completely give away the task of maintaining it, but we will take it because there's interaction, right? There were biggest problem that we don't have, or sometimes it's hard. This is a new model, and there's always an existing one. It's almost like trying to change the things on the airplane that's flying, and some of these are very critical systems. It would be nice to have a quick A/B testing model. We know how to do this for front end. When you try to bring this A/B testing model, hey, give me some % of traffic, and I'm not even going to give it back to you. I'm just going to ghost. That's not always easy. And, we operate on a Python, Java world, but, everything is services. We can do it. But in some cases, even that API services discussion doesn't go in place. So it's short version is case by case. We've seen everything. You guys may have other examples of, trials and tribulations, I would say.
Love to hear more, but you know what? I want to leave time for Q&A, and we're running a little bit short on time, so I'm just going to ask the panelists to keep their responses a bit more concise so we can get through everything. But thank you, Jem. That was wonderful, wonderful insight. And Gaurav, I wanted to ask you. We touched on a few of the security risks already related to AI models within the industry, but maybe you can elaborate a bit more on what security challenges, in your eyes, need to be addressed in order to encourage the adoption or the continued adoption of AI within healthcare.
Right. So we talked about just the security aspect of it, but I think security can also play a very important role in terms of adoption. Ravindra and Jem were talking about the whole concept of data sharing. The data is spread out, different formats, and it's not a consolidated, centralized repository. And as Mitali was talking about, from a data strategy perspective, data sharing, data access is very important to make sure that the level of insights are more accurate. And this is where security can come into the picture, is how do we share this data, which most of the times is not with a single owner. This data is spread across the organization. It sometimes is spread intra-organization. We are working with intra-organization, with 4 healthcare providers that have their own data sets, but they have a common model that is being trained on these 4 different data sets that they have to become a more accurate way for predicting some of the insights. So how do we make it happen is where security plays a role in, is how do we expose the data without really compromising it? How do we share it without really having people unfettered access where just the model can access it? And there are various different techniques that I would touch on later on.
Okay, great, thank you. Matul, a question for you. How can AI within the healthcare sector avoid the hype or the lofty expectations that have plagued the digital healthcare sector until now?
Yeah, it's a good question. I think, from a product perspective, I think it's very easy, and especially in today's, ways of being able to disseminate information through social media. There's a large risk of hyping AI to the point where expectations are running faster than what the technology is actually providing in terms of benefits. And so I think there's a large risk of, and most likely misconceptions that are supporting, AI, for example, replacing individuals, physicians, doctors, AI listening and taking data and PHI and being able to use it for purposes that are not, they're unscrupulous. So it's really important that I think for AI and healthcare to get off its feet is to be able to set the tone away from the disinformation, but more into the impact. As I was mentioning, more activity on the ground, more activity working in the workflow of the physician, and working ultimately to see impact for the patients. I think that's going to speak louder than the other issues that are related to AI that I think distract from what the actual true benefits can be. And so, at Proscia and wherever I've been, our number one, kind of goal is to be able to, as Mitali mentioned, talk to the user, being able to understand the users and being able to understand what's important to them. But then what's interesting, and I think is a challenge, is that oftentimes they know what they know their workflow. It's up to the product and really the company to be able to derive, well, you haven't seen AI into your workflow. What haven't you said that we can incorporate to help you even more? What are the questions you're not asking? And I think that's something that we as individuals in AI and healthcare can really shape and be able to, again, provide the positive impact that we can make beyond, the misconceptions that are out there.
Thank you, Matul. And Senthil, maybe you can piggyback off that and talk a little bit about COVID-19's impact on the development of telehealth initiatives, which you were part of.
Yeah, I think everybody probably knows this by this time. During COVID, telehealth traffic spiked. Across the industry, people noticed like 900% increase to some companies experiencing like a 1300% increase. So we had like close to 1,000% increase in our traffic at Virtuwell. So it's a lot more challenging, isn't it? When your thing goes up 30-40%, it's a lot easier to handle. So we did a lot of we were already in private cloud, so that wasn't a bigger issue from container SQL tuning and all these technology stuff. So I don't want to bore this panel on how we did this cloud infrastructure changes. But on the AI front, what we did was we figured out how we need to improve our provider scheduling. How do we need to route the patients to providers? And predicting follow-ups is where we became a little better at. Who's going to come for a follow-up? When are they going to come for a follow-up? How can the system help them respond? Try to minimize the provider burnout by providing a lot of filtering options. So a lot was done on getting the diagnosis faster, also making it accurate, even though our traffic spiked. So we also partnered with the Capsule, for instance, on the prescription delivery, because not all pharmacies are 24/7. So and also the pharmacy hours during COVID also changed. So we had to get the right prescription at the right time. So partnering with Capsule, which is a prescription delivery company to your doorstep, really helped a lot of patients. So they did the prescription delivery within like a couple of hours or something like that, which really helped during pandemic. These were some of the initiatives. So
for sharing with us some of that. I want to move on to our last topic, just for the sake of time. We're about an hour in, and hopefully we will have at least 15 minutes, if we can get through the next 15 minutes, 15 minutes left for Q&A. So I encourage our audience members to share any questions they may have now, so we can maybe gauge the amount of time we should allot for it. So I'm just going to jump into our last and final topic, which is approaches and solutions of AI within healthcare. And I'll start off with Dutta by asking maybe for some practical tips that you can provide us with for building a successful AI ML data strategy. And we already spoke about this already, and we touched upon it in a few other answers, but maybe you can provide us with a few more insights.
Thank you, Shirley. I guess when you attach the word practical for the audience, typically I think all of us here who are in the panel, being into this world, know that the first practical thing for any AML data strategy for us is to make sure we keep in mind the success KPIs. When we start, we have to really think doing it would bring what success, and definition of a success, it depends upon the user we already spoke about. And when we think of a success, then comes again the third heart of the practical parts. I'm using heart in a lot of places. We are in the healthcare. So it is the business problem. It is the transformation goal of the company that we belong to. So first thing in any practical scenario is the success. Think about it. Think about the business problem that the strategy or AIML will solve. Think about the transformation goal that brings in. Very practical tip for anybody while they start. The second is any data strategy or any data practically when it comes, you can mind map, and within our company, we actually have brought in a construct which divides the data into 120-degree, 240-degree, and a 360-degree. 360 is a very common terminology these days in the industry, but do understand that what is that 120-degree of the strategy of the data that can give you maximum information about the master information, master construct. Then comes the 240-degree, which is the performance construct. What exactly is data going to give you the measurement around performance parameters? And the last, then comes the 360-degree, which is the exploration, which is the health, which is where you understand where are the possibilities to improve, optimize, find the new opportunity, find the new white space for the growth, or find what Mitul mentioned, that the impact you can bring when this thing will come out. So 120, 240, and 360, start mind mapping, start to pin down in practically what construct of the data can be used. Last but not the least practical advice, cost effectiveness. Do what you want, but if it's not a cost effective solution, nobody's going to take it. Which also Sam mentioned that when he went finally for the deployment, it ended up becoming such an expensive solution that the AML could not be fitted back to the consumption party. So do keep in mind when you're doing the data strategy that you think of the cost effectiveness. You unnecessarily don't include technology into it, which is not required. Right? So those are the three practical advice, Shirley, from my side. Thank you.
Wonderful, thank you. Mitul, a question for you. Where can AI provide, in your opinion, the largest impact when it comes to automation of diagnostics or just general workload?
Yeah, I think it was mentioned before, and I think it's worth emphasizing again that, where I believe AI has I think AI plays a role specifically in where I work in two different areas. One in diagnostic, triaging, prognostic type of applications. So being able to, for medical imaging, review cases and be able to triage them so they can go to the right individual. And then once they're with your right individual, to be able to provide a diagnostic and perhaps some indicator for the growth, let's say, of a lesion and what we should do in the future, and provide that information to the physician. That's one area. The second area, which I think is the most interesting, and I think the most obvious, but I don't think it's really, investigated as much, is really with the idea of process automation. So utilizing AI in the background, I think someone mentioned, being able to understand and almost do an ethnographic study, in my case, in the lab. Once the sample comes in from the physician, the tissue sample, and then gets eventually over and stained and then scanned and then put in front of the pathologist, what's the ethnographic kind of results of that whole process? There are, so many different items that are happening all in the background. Where can we take where there's a high level of human error, where we need a standardization of performance, and be able to integrate and employ AI to support all of those operations that are going on in the background, such as quality control, or being able to conduct or employ AI in service of process automation to help the lab work more efficiently, or the emergency room, or whatever the location and the situation of where the AI is working, and to be able to have that working in the background and making ultimately the individuals who are working in their jobs do what they do really, really well, which is what they're trained to do. Perhaps a physician, becoming and really doing a physician as opposed to writing reports. The lab technician working on, items that they're trained to do as opposed to other items that, let's say, AI can do. And so I think that's where I think there's a large amount of potential and impact that AI can make in general. And it's the matter of really getting into and understanding the ethnographic kind of rampant circumstances that AI can actually work on.
Interesting. And so build off of that for us. What in your eyes is the future of AI for digital diagnostics technology?
Oh, just wanted, maybe Mitul knows more about on this prostate cancer detection. Page or somebody did some AI automation, isn't it, Mitul? So there are a lot that's happening on the digital therapy to reduce anxiety, OCD. There's a lot on the different sections of cancer diagnostics. I'm pretty excited about the digital dermatology because before pandemic, only 14% of users have ever used a tele dermatology. But American Association of Dermatology last month said, like, during pandemic, 95% of people used teledermatology in the United States. So that's a significant number. And once you digitize all of the data and predict skin diagnosis through that, so then that helps in a lot more cost saving and hopefully a lot more automation and hopefully a lot more accuracy. So I'm pretty excited on the digital diagnostic sites because we are actually working on how do we systematically route the patient cases to like how do we utilize our decision support system, and how do we route it to the right clinician at the right time. So these are some significant challenges, but at the same time, it's also happening as we speak on the digital diagnostic side.
Fascinating. Gaurav, talk to us a little bit more about solutions or approaches to protecting healthcare data within AI models.
Yeah, so I see a question from Dejan in the chat window. I think I'm going to use that as a basis. So there are a couple of different approaches from a security and a privacy perspective that the healthcare industry has adopted. Number one being data anonymization. And that, you can anonymize completely and you can lose the efficacy of the data to provide insights. And you can do a little bit and it's, it still has some privacy challenges. So how do you solve that? So there are other approaches that can help mitigate that. Number one approach that a lot of healthcare industry practitioners are adopting is called Federated Learning, which is you have the data sets spread out, the model goes out and it learns, in a federated manner. Solutions like TensorFlow have that. But there are a bunch of other approaches to that in the market. That's one approach, but it still has the problem of data still being in the open. So it needs augmentation. There's another approach called differential privacy, where you remove certain aspects to anonymize the data in a more effective manner, and you use that to operate the model on top of the data. There is a very nascent field of homomorphic encryption, where you encrypt the data, but it is extremely computationally expensive at this given point of time. And then there is the approach of confidential computing, which essentially creates isolated environments. And you can separate those environments based on a hardware-based approach or a software-based approach. But you isolate the data sets, you isolate the model, and with that, you reduce the requirement to do anonymization, and help the model really operate on the real data rather than working on a heavily anonymized data set. So I hope I answered that question.
Jim, what are some of the ways that you highlight the advantages of oftentimes expensive machine learning solutions when you're talking to internal customers?
Tough one. So I'll give you a couple of examples that were successful or I deem to be successful. And we actually demo our solutions sometimes to the internal customers. It's subsidy of the company. Sometimes it's a new project. So we go in front of the executives or, sometimes engineers to show them what is possible. I'm going to highlight two examples. One is one of the companies we own is Vivify, which is, home care is going to be big. It's only getting bigger. Everybody, the patients want to stay home. They don't want to go to hospital. Hospital don't want them. We learned our lesson in COVID. Physicians don't want to see people unnecessarily. And the insurance doesn't want them to end in urgent care. If we're lucky, it could be emergency. So Vivify actually tries to collect information. There is a lot of devices you can keep at home, iPads and other sensors. And of course, the problem is you collect this, which is a beautiful way of, spreading healthcare, remote healthcare to more people, because you can do a lot more with devices. IoT is only going to get bigger. We know this, So, and at Vivify, and then at that point, the problem is this. You're going to collect all this information. The nurses, agents are looking at the list of, who's at risk. So we actually build a system by looking at the data. We try to highlight who are the high-risk patients or who are the patients you need to pay attention on that specific day. You give them a ranked list. Now, which is okay, you give them a ranked list. There is a number associated. It's a score, 0.98 for the first person, 0.97 for the second one. The problem in the user's mind in front of that dashboard is why? Why am I looking at this guy? What am I missing at the bottom? So actually, one of our data scientists actually come up with this very nice way of explaining that score in English. So everything they see in this model, and the user have no idea what we're doing in the backend. It could be extremely complex, but they try to explain it. This is happening because these two numbers are up. And then the next step was, which is very interesting, the agent gets to define those ranges. They can say, look, show me, the high blood pressure, if it goes up to this one and has this one, show me those first. And we auto adjust and they get to override and they get to pick the model without realizing what the model is doing. So we're actually testing those ideas. This was very successful. And it's getting traction, and everybody loves it. The other one is the things. These are very recent, by the way. The document search. I'm part of search now, so I only obsess about search these days when it comes to claims and documents and etc. So one example that I'm going to give you is this: the query from the consumer is going to be, "I broke my tooth at work." That is the query, and you can understand why. This could be an Alexa query too, right? We were actually able to bring, and we can bring a lot of things. One of the things is on their benefits documents, on all the policies we have, we actually put accidental dental coverage in network right at the top. And that document doesn't have anything about breaking a tooth at work. But we make that connection, and it's very fast. So by demonstrating these, we're actually going in front of the customer saying that, look, there is a lot more that AI can do for you. And these are the things that some of these are, the example I've given you is based on embeddings. Without embeddings, you're not going to get this. And then on top of embeddings in front of our search engine, there is something else that we call bubbles. We're trying to patent that idea. So there's all query to intent to document. So when you show these things, you can actually get traction. That's how we're trying to bring it to the next level, the Web3 or the next version of the software, AI, ML in healthcare. So we do it by proof of concepts, which is very powerful for us.
Thank you, Jem. I have a final question, and then we'll move on to Q&A. Ravindra, building off of what Jem just discussed, how do you define value creation associated with AI models when talking to internal customers?
Yeah, this is a question I guess everybody gets it, right? So if we are investing so much, what's the value that you are returning back with respect to all the investment that's happening with data and AI? One of the key point is, before we go on defining the value, it's about wearing the customer hat. I use it colloquially. The customer it could be a patient, consumer, or a physician or a clinician here, right? what's the value being associated for solving their problem. So, for example, is it improving the patient experience or the staff experience? The ML model could be built across, but to find a lesion or a tumor. But if a radiologist has to click 15 clicks to get the report out, that's not what we want to have, right? That's a poor experience what people or the end user is going to get it, right? So the value creation is about how do you assist the end user to reduce the amount of work, very specifically in healthcare if they are clinicians, although it will be a long time before we even can make a claim that they will not be in the loop. But it would be still, how can you associate a value by reducing the burden such that their burnout is reduced? That's one of the way to look out for value creation. The second one I can also see is in e-com or others, it's very easy, right? The recommendation system came in and then people clicked it or they watched it, and that was the revenue that is getting associated with the value that is being generated. But here it's little different, right? It's about the new innovation excellence that you brought in, right? Did you evade the competitors in other sense, right? So that's one of the way to look at the value creation in terms of AI. And finally, it's about a better health outcome. People come to the healthcare system and it is not enjoyable for them, right? They come because they have a challenge. And for us, it is about improving their health outcome with respect to AI, delivering the value. That's one. And finally, it is all about reducing the cost of the care. If we can find in a single scan all the incidental findings which were supposed to be missed by a radiologist, then it's a value delivered by the AI, right? He or she don't need to go for a CT scan twice. A single CT scan has both the anomalies being detected, which was potentially could have missed, right? That's the value being created by the AI. So these are a couple of examples and associated use cases.
Thank you, Ravindra. Did anyone want to add anything onto this point before we move on to Q&A?
No, I guess clearly recognize what Ravindra just mentioned, and also relating to the success KPIs that I spoke. This is exactly the center of the heart to figure out what is the value, what is the success, define it, and before you do anything, define it, and then you know what you built will be successful. So completely agree to what Ravindra mentioned.
Okay, and with that, we wrap up our discussion segment of this evening. So thank you to our wonderful panelists for your vast and wonderful insights. I want to take the opportunity now to open up the floor to our audience members. We have a few questions here in the chat and at least one in the Q&A. So if you have, I'm talking to our audience members, if you have any other to contribute, or you have something that's itching you in the back of your brain, there's no question that's a stupid question. All questions are welcome. So feel free to share. So one of the questions we received here in the chat is, what is the scope of AI in healthcare administration when it comes to, for example, billing and claim management? Does anyone have anything to...
I can take that. So I want to take a parallel, and I would like to answer this on the auto insurance. I don't know how many people are following on the car insurance side. We have close to 7 or 8 million car crashes every year in the United States, more than 20 million car insurance claims. And last year in 2021 or 2020, I don't remember the year, where 9 million claims was processed through a deep learning solution. And that created the line-by-line item on the insurance claim processing. So this exists in the other industry. Does it exist inside the healthcare industry? I think it's the right time that it comes into the insurance billing, in the claims processing in the health side. At least at Virtuwell, where I work, we have the know your cost. And so that provides what is going to be your expected cost before even you start the service. So that's kind of like something that is needed right now on any clinic visit or any hospital visit. Can I know my cost? what's going to be my min, max, or mid at the least? So that's the ask of the hour. And the auto industry has somehow figured it out. And now the deep learning algorithms are there. So it is a constant work in progress. And I just want to mention whoever has asked that it is happening as we speak.
I can add a couple of things. The projects that I was involved with both with billing and claims. So we have a couple of things that we looked at. First of all, I mean, we receive a lot of documents that are not digital. So taking those documents and then bring them into the system is a big process. And, you know, this could be, and we work with multiple different states, multiple different care organizations. So you can't control what's coming your way. So there's a lot of AI ML components that, you know, just does the injection. So there's one. We actually tried to figure out if we can do a good job with price transparency. Like we took one example, lumbar fusion, and look at all the history for all the people with lumbar fusion and try to get an idea based on their definitions of where they are, you know, how old they are, etc., to give an idea. This is going to be your cost based on what we've seen before, which is very interesting. Not an easy one, but we were desperate to try. Auto education is another one. There is a huge drive to automatically make decisions for at least the simple cases, if we can guarantee. And, you know, when you try to do work on these, the biggest questions we get from people who are, you know, watching this very carefully is, can you guarantee that you're using the same logic, business logic, for everybody? Because so far everything is based on rule-based systems, and it's very easy to explain rule-based systems, saying that, hey, this is what happened. If you go, when you go to deep learning, suddenly the explainability is a little bit out the door. So there is a drive because, you know, you have to show FDA that we're doing the right things. And, you know, this is these models actually going to update maybe even weekly because CI/CD is all over the place. So, you know, how do we guarantee that we're going to make changes, but it's always stable and it's always meaningful and explainable and fair? So that's an interesting topic. But it is definitely happening. We're trying because we know we have to do that.
I have another question here. Thank you, Jem. I have another question here from one of our audience members. Hi, everyone. I'm Jerry Najowski. Sorry if I'm mispronouncing your name. I spent many decades deploying clinical claims and financial systems for a company. The only constant was change. How do you ensure that vendor software or workflow changes, planned or otherwise unplanned, upstream in the data feeds do not unintentionally blow up or otherwise invalidate the AI ML models that are in production? How do you continuously validate them?
Yeah, I can take a stab.
Should I repeat the question? I can also. Okay,
Yeah,
go ahead.
I can repeat the question. Now, one is the robust MLOps, right? Although the terminology has been currently being used, however, it has not been given so much of attention. Reason being only a few models and so on were currently deployed, but that is this part, having a robust MLOps in the entire way, how we deploy the models, would help to a certain extent to make sure these models are always up to date. Having the right guardrails on data drift, the model drift being ensured appropriately within your loop is one of the defining parameter to ensure that the model doesn't die. And obviously, some of the panelists also brought out that building AI model is not just done and dusted, right? It needs that effort to maintain, and this is what the MLOps brings in to it.
Yeah, I have a couple of comments on that one. So yeah, the word we're looking for is MLOps. I mean, it used to be DevOps. Now there's a part, I mean, it's concentrating on machine learning. That's why, you know, we're reading all these books that we need to do because we want to do it together. I mean, I don't want to solve it for myself. I want to solve it for everybody. The CI/CD tools are in a good place. So you can, I mean, if you have, I'm going to talk engineering because I'm an engineer. If you have good engineers, they can pull that off. There are a couple of rules. I mean, there are two things that I'm actually pushing aggressively. One is don't trust anybody's data. If you don't have a schema for the data that you're taking in, don't take it in. If they don't give you a schema, create your own. Let's make sure we're stable because things are going to change. We know that the JSON files lose a field just like that on the fly, right? The other one is if you're generating something, generate based on a schema. Don't generate anything unless you have a schema. Schema first. So that kind of guarantees the integration points. The other one is actually I'm starting just like code reviews for software that we're building. We're gonna create content reviews. I want as a group look at the content that's coming in so we all understand what's in there because I may miss something when I dig it. And of course the rule is look at millions. 10,000 is not the number. The number is million. We want to label some data to do something. We work with third-party companies to speed that up. We're not going to build it ourselves, but the number is always a million. I should be able to label million things. I should be able to look at million things. So there's a lot of tooling, but MLOps kind of started defining those. And the model is it's a standard software model. Iterate at every step and test every step. And Jenkins is your friend because we love it. That's my short version.
Okay, I have one final question, and then we're going to wrap things up. Do you want the question about the metaverse or the question about facts?
What is metaverse?
Okay, so let's go with the facts. The metaverse, Mark Zuckerberg's dystopian digital future for us. Sorry to anyone who works at Meta, who, by the way, is like trying to constantly recruit me, and I'm like, oh God, I could never work there. Side point. That's our last question here. Today, with the software stacks you use, is it possible to forget a subset of trained quote-unquote facts, or to age out older quote-unquote facts without having to retrain the entire model?
Yes. There are 3 different design patterns for machine learning. Read the book that look at this stuff. I mean, you train something, next week it's going to change. I mean, the example that I give everybody, look, if you were doing search, or if you're Google and you're very good with healthcare searches, right? Suddenly out of nowhere, 2 things came up. Multiple things came up. First, it was COVID. People start typing COVID. You have nothing for it. That's new data. You have to, how are you going to train your embeddings to understand COVID, then Delta, then Omicron? At some point, bleach become big. And we actually built for our POC, I made sure that we have this skill, dynamic skill that any product manager can go into GitHub, type in something, and for a specific query, you override everything. Like for bleach, I have to put on top of my results, this is poison, read from CDC website, nothing else. Don't do anything else. We were able to actually plug that in 5 minutes from somebody typing it to production. That's the speed we want. Yeah, there is definitely adjustment. You need a manual solution, but there is a lot of different models on the discussion centers around, okay, so you're going to take the data, you're going to merge it. Somebody just came up with an idea, which is not new, but people were discussing on Twitter, no less, that you take the old data, you take the new data, you actually mark the old data as 0 failure, and then new data as 1, and you try to learn that. There are ideas around, okay, so you have hyperparameters, how are we going to retrain them? Do you take the old data, new data? Do you merge them? There's a lot of different ideas. Yes, Facebook trains their newsfeed every month to the cost of, I don't know, tens of millions of dollars. You can't do that. You don't have that kind of money. And we don't have that kind of data, thank God. But, we're still learning. There's still new patterns coming up. But honestly, every week there is a new idea around how do I retrain? How do I forget, or how do I not forget? Because there are things you want to forget. There are things you don't want to forget. The question is, which one is which? We don't know. And every field is different. It's different for claims. It's different for queries. It's different for clinical. The example is COVID, Omicron. That's a new word.
Anyone else want to add anything to that?
I might just add a few words to it. So I think very well explained, Sam. And typically any model building, your dynamicity has to be maintained. You need to make sure the CI/CD process and machine learning operations, they take care of the dynamic inputs of the facts. At times, dimensions also changes. So facts and dimensions are the core to any data model technique. And within that, some facts you can see over a period of 10 years or 20 years keeps changing at times. But you also want to keep them rather than you want to unlearn them, but but you do want to keep them in the data. You don't want to just forget them at times, right? So the dynamic way of managing your facts is also the data modeling technique, or you can use data mesh as a technique to make sure that you keep in mind, keep them in your repository, but you only use in your new training data, because in the CI/CD process, your models might be refreshing daily, weekly, monthly, hourly, it can be any frequency. So you can make sure that you make them active or inactive, and your model should be able to pick it up. So that dynamicity is very important now in AML. Without dynamic fact management, you cannot sustain models.
Thank you, Dutta. Okay, and with that, we're going to wrap things up. Thank you, everyone, for joining us, and thank you to our wonderful speakers for a great discussion, including Senthil, Kumaran, Dutta, Mitali, Matul Shah, Jem, Unsal, and Ravindra Patil. And last but not least, I don't want to forget Gaurav Sharma. Thank you guys all for joining us and for a wonderful discussion. I hope that everyone is staying safe and healthy, and I look forward to hosting many more discussions like these in the future. So feel free to follow Hub Security on LinkedIn. We're also on Twitter. If you want to find a recording of this event, you'll be able to find it at Hub Security's YouTube channel on YouTube. And feel free to share it with anyone who you think might find it interesting. And finally, if you would like to get in touch with any of today's panelists, you'll be able to reach out to them directly. All of today's attendees will be receiving an email in the coming days with the contact information, excuse me, for each of our panelists. So don't be afraid to drop them a line if you have any other further questions on any of today's topics. Thank you once again to our panelists. It was a pleasure to host you, and I hope to see you guys again soon.
Thank you very much.
Thank you. Thank you, Lori.
Thank you very much.
Thank you, everyone. Bye-bye.
Thank you.